Hello, I'm Connor Hall, and this is using Batman software to analyze metabolic changes in type 1 diabetes-susceptible rats. Lu1WR1 rats were used in this study due to their being shown to be susceptible to type 1 diabetes. They are used as models for type 1 diabetes to study the different mechanisms of the disease and its progression in humans. Nuclear magnetic resonance, or NMR, is a method of analysis that uses a magnetic field to produce a spectrum of data points which often is characteristic of the components of the system. NMR was used in this study to analyze the metabolites in urine due to the richness of the data provided by NMR. Due to the large amount of data and need to process multiple spectra at a time, the Batman software package was chosen due to its ability to process multiple spectra at a time and produce concentration data without the need for manual integration, which is the typical method of analyzing NMR spectra. This software package uses Bayesian statistical curve fitting to produce a curve similar to the original spectrum. During this process, certain parameters are used and can be varied by the user. The DSS peak, the reference peak for all other peaks in the spectrum, is first fit properly using the peak width parameter, which gives the global mean peak width, and then using the chemical shift R delta parameter, which gives the variability of the peak away from the standard chemical shift, which is 0.0 for DSS. The photo shown shows the R delta parameter for peaks such as the 2.5 peak, which is citric acid. It is shown in the difference between the two spectra shown. Each metabolite is analyzed and fit using the specific R delta parameters that is part of one of the files. If there is too much variability from the standard chemical shift, there is a file given called the ChemShift per spectrum file, which can be edited to specify the chemical shift for each spectrum when analyzing multiple spectra at a time. A MATLAB program was also provided with this software to edit the ChemShift per spectrum file to make it easier to specify the chemical shift for each spectrum by providing a graphical user interface. Some of the strengths of this program are in fitting large and small concentration metabolites. Large concentration metabolites such as citric acid, succinic acid, oxoglutaric acid, and acetoacetic acid are fit very well and fairly easily by the Batman software package, as seen in the spectra shown on this slide for the metabolites. As opposed to manual integration, it is fairly easy for Batman to deconvolve overlapping peaks, such as in the case of the acetoacetic acid singlet that is convoluted with the triplet in the spectrum shown. Batman, in this way, can take partials of peaks and analyze them based on what is given as the reference data for that specific peak. As mentioned before, small concentration metabolites are also fit well by the Batman software, as seen in the spectra for hydroxybutyric acid, alanine, and valine. Each spectrum shown has a lot of noise, but the Batman software successfully deconvolves this noise into meaningful peaks, such as the perfectly fit doublet of alanine that's shown, as well as all of the peaks for hydroxybutyric acid and valine. Some of the challenges faced during this study included time spent running calculations, computer processing power, and storage requirements, and dealing with large chemical shift variability on some of the peaks. The time spent waiting on calculations to finish often amounted to over an hour per run, and the methods used are iterative, so fitting a set of spectra well took a lot of time. The computer processing power needed was very high, and the storage requirements were extreme, with each run of calculations typically taking a gigabyte of storage space. Also, the large chemical shift variability present in some peaks, such as citric acid, proved difficult to work around with the Batman software and the R delta being too large and fitting the wrong peak at times when this was the case. While there were these challenges, Batman is still a very good software due to the capabilities and power of Bayesian statistical modeling. Any questions can be sent to my email at connor.hall@uah.edu.